Electric circuit potential. When we turn on a switch, the bulb lights, the fan turns, and the television works. All this is made possible by electricity. Electricity plays an important role in our daily life. It is a controllable and convenient form of energy for a variety of applications such as lights, fans, working of motors, etc. Electricity is caused by the flow of charged particles. Charged particles exist all around us. Greek philosophers noticed that when a piece of amber was rubbed with cloth, it would attract pieces of straw. They recorded the first references to electrical effects such as static electricity and lightning over 2,500 years ago. What is an electric charge? Now let us look at the structure of an atom to understand this concept of electric charge better. The atoms that constitute most matter we encounter contain particles called protons, neutrons, and electrons. Protons and electrons have one unit charge, but of opposite sign. Protons have what we call a positive charge. Electrons have a negative charge. Neutrons have no charge. They are neutral. Atoms are generally neutral because the number of electrons and protons are the same. The movement of electric charge is known as an electric current. Current can consist of any moving charged particles. Most commonly, these are electrons. But any charge in motion constitutes a current. What is an electric circuit? A continuous and closed path of an electric current is called an electric circuit. A battery is a chemical device that stores charges. A copper wire conducts electrons from one point to another. A switch allows us to keep a circuit open or closed. Consider an electric circuit consisting of a switch, battery, and a bulb. All the three are connected by a metallic wire. When the switch is on, the bulb glows. This is because when the switch is closed, the current will flow from the battery and the bulb will glow. If the circuit is broken anywhere, then current stops flowing and the bulb does not glow. From this experiment, we have understood that an electric circuit is a continuous and closed path of an electric current. Why do electrons flow from one point to another? Consider an experimental setup of a pipe and a container holding water connected through a stopcock. The quantity of water in pipe is less than the quantity of container, but the level of water is higher than the level in container. When you open the stopcock, this water begins to flow from pipe to container till the level of water in both the pipe and the container are equal. This experiment shows that it is not the quantity of water but the level of water which decides the direction of flow of water. Here, the water in pipe is at a higher gravitational potential and the water in the container is at a lower gravitational potential. It is the gravitational potential difference that is responsible for the flow of water. In a conducting metallic wire, electrons flow only if there is a difference in electric pressure. This is called potential difference. This potential difference can be achieved by a battery consisting of one or more cells. In the case of the water, the higher the level of water in the pipe, the faster will be the flow of water to the container. Similarly, in the case of electrons, The greater the potential difference, the faster will be the flow of electrons. Higher the voltage, the battery will create a greater flow of current. Let us construct a circuit using switch, battery, bulb, and an ammeter. An ammeter is used to measure the electric current. Small quantities of current is expressed in milliammeter. 1 milliampere equal to 10 to the power of -3 ampere. And microammeters. 1 microampere equal to 10 to the power of -6 ampere. We can see the deflection in the ammeter when it is connected to the circuit and the switch is closed. The electric current is expressed by the amount of charge flowing through a particular area in unit time. If a net charge Q flows across any cross-section of a conductor in time t, then the current I passed through the cross-section is I is equal to Q by T. Now let's connect a voltmeter to the circuit. Voltmeter is used to measure the potential difference. When the switch is closed, the pointer of the voltmeter deflects. Now let's change the battery connected to the circuits. We can see that when the battery is changed, a subsequent change happens to the reading in the voltmeter. Have you ever wondered how lightning happens? Why do you get an electric shock when you touch a leaking switch? Let us now learn about all these in detail. Lightning is the result of the separation of charges within the cloud. Lightning occurs when the attraction between the negative charges at the bottom of the cloud and the positive charges on the ground is strong enough. The lightning we see is actually the return stroke when the positive charges move up to the cloud. Upon contact of a human body with the leaking switch, leakage power flows to the body, and if it's high enough to cause sufficient current to the skin, the body gets electric shock. The minimum current a human can feel is thought to be about 1 milliampere. In this lesson, we have learned about electric charges, electric current, and circuits. Here is a problem for you to solve. Why should you avoid touching metal objects during a thunderstorm? Think and find the answer yourself.